So after showing how everything works, let me show you what we actually built when we did the PscgBuildOS for the AMLogic, because we built an entire image along with the entire boot chain. So I started with wrapper all args that you've seen before, but this guy actually went and it built BusyBox.os, AlpineOS, DebianOS, which the AMLogic build also supports all of them, okay? For all the architectures and that they were meant to be run in QEMU and creating their images and so on and so forth. So out of that, I made like a file that instead of building like all of them, just builds one architecture. If I just want to repackage a hard drive and check like a RAM disk and check some things there. So I made something like this. And the differences from it would be this. First of all, so on the right hand side I have like the build AMLogic. So I made all like this true, not true. By default all of them would be true, okay? Maybe except for the build DTBs, but I think all of them would be true, so we can just get rid of them. We don't need to generate a QEMU script. We could if we want to, as long as we have like the vert.io kernel configuration supported there, which are there by default. What we do have, which is very important, is this. We have like this if false that I would usually do, but then if here I did not want to share the build of the kernel because then if I want to build QEMU system, then via like the other script, then it would just take more time and I did not want to do it. But the very important thing here that might be moved out of this project, out of the PscgBuildOS, like to an external layer, is layers BSP, recipes, Linux, and then the name of this, which I will show very soon. This has all the definitions. At the moment I give a config BSP layer, the build system PscgBuildOS knows how to process it. And I covered it in very earlier videos. Other than that, I just wanted to build one thing, either PscgBuildOS or a PscgBusyBox, which I've done here. And I set some other variables, like this is an example because this is like the first project where you actually build U-boot in the public project. There is a private project where there are so many things that are built, but you're not exposed to it. And I also added like a feature to set like the URL to my local folder here, so for the OTA, because otherwise there is like something for development that like identifies the URL. So this is one thing. The other thing, I deliberately put it like in another output directory so that it's noticeable that I've done it. And other than that, the imaging is a little bit different than like the default. Now why? Because in the default image of QEMU, just say, okay, just make everything like very big. I don't care. Let's keep the Debian caches in it. I don't care. And then the image overall, like with the double redundancy, with the recovery packages, with everything, could be something like 20 gigs. Now, here there is a trade-off actually on whether we want to keep like the caches or not. I always say that we want to keep them just to build much faster. This is only in the DevOps, in the Debian or Ubuntu-based system. However, if we do that, then each of the partitions will be pretty big. And if I want to flash it into an EMC that has like 8 gigs or like 16 gigs, then it's not very possible. So one needs to be smarter around it. So if it's PSCG, I added like another like partition in scheme, okay, and also changed the default, I think, in the code. And otherwise, it turned out that like the partition that I had, like the 50 megs for a BusyBox, I don't remember what exactly I added. Maybe it's because I added some more assets or something like that. But I needed to increase the system partitions. Like 50 megs would not be enough. Okay, I know exactly for what. For like for OTAing it. So, and like keeping it. So that's fine. I mean, if there is not like system overlay, otherwise it's fine because it wouldn't get to the read-only partition. So these are the only changes, okay? So having said that, we can go ahead and concentrate on the PSP layer. Now, there is a mechanism that if the config BSP layer, I will not show it, I will just concentrate on the BSP layer itself, okay? If the mechanism starts like with slash, then it will be like an absolute path. If it starts with layers, then it's going to look under the main project. So I open like a VS Code here. Let's look at the main project. And the main project, like under layers, there are all those BSPs that are from the QEMU. And under, and this is like the BSP that we have here. So I called the layer BSP AMLogic S905WP281. Each layer is like the BSP build config. And here I said that the product could support like several ones. I said, okay, this is AMLogic S905. This is the console device, T2i ML0. In many other devices, it would be T2i CM0, T2i S0, and so on and so forth. But this is what I decided to do. And then source local dir just tell me, hey, like, make like the local dir variable for this particular file that is being sourced. That's fine. So here I source the common file and config BSP product, which is this guy here, dot build config. And after doing it, I go to the list of the common bootloaders to build, which is then, and I just source the bootloaders build config there. Okay. And that's what I'm going to do. All right, so that's what I'm doing. And in addition to it, then actually this one, yeah, that's fine. So like the B is like the name of bootloader, like uboot or like ext linux or like grub and so on. The idea is that I go from the more specific to the less specific. This is what I do when I have like a build config, when I have like shell scripts, shell functions that are going to be overridden, then I do it from the less specific and then the next line with the more specific. This is not the case here. So let's see what this variable here is, okay? So this is all like for the main BSP file that is being sourced from the build system anyway. So here, and by the way, I could change things like on the fly. I'm sort of like doing code review to myself. And if I change, then I change. I don't really feel to do it again. I think that I put tons of comments. Let's just put a tab here so that they'll be like on the same line, because why not? And here's the thing. We want to build a kernel here, okay? We have like specific things here. We want to build the firmware. We don't want to build the core boot or like the firm or EDK or the firmware file themselves. And here we're not going to build the ARM trusted firmware. We could actually, and in one of the courses we do it for this BSP as well, but in this example we do not do it. Now the common bootloaders that we want to build, it's important, like the common ones are going to be like from the common code, okay? So we have here like in the code like uboot, x linux grub, and I select like some very specific things. Perhaps I should change some of like the folders here, like these are being used like in the common mechanism that I will show perhaps later. So here we don't build like another firmware. Here for the bootloaders we do uboot, and the config BSP bootloader, that is what I'm going to set the files for. Maybe I will also make a list here, is going to be ext linux. And the reason for it is that mainline uboot supports, like this year in 2026, it supports, and also a couple of years ago, it supports boot distro. That boot distro boot, sorry, it's going to look if there is like ext linux or sys linux or something like that, and just load a config file, and then you don't need to make like a header, a uboot header with make image, as you would do like in regular legacy uboot. So it's easier for people to modify, and then if you have like the file on an SD card, that it's easier to modify. It's a little bit harder to control when you want to stop in the bootloader itself, but then you can still use like the U-boot jargon. So this is actually just a little hack because I wanted to make sure that if I build like a very small image, then the image size is very small. Why did I do that? Because I want to flash to a device and I don't want to wait time when I DD. Okay, so I want in the imager, just like with the other imager, the installer, pscg install label, I will have like one fat partition where all the materials will reside. And before that, as you saw like in the previous videos, I want to have like the AMLogic boot chain code. So it will be in the 4 sectors. If I want to also provide environment, then I'm going to make it like, in this case, I think I put it like on the 3 megabyte mark. Okay, so this is down there, and here I did more things, like I put some hooks in the image creation in the imager script of the PscgBuildOS to run right before doing the image and right after doing the image. Now why would I want to do that? Because maybe before I want to copy more things like to the work directory, for example like the ext Linux files, okay, perhaps. And after that, let's say if I create like everything, maybe I want to encrypt the image, maybe, or like some of like the images that are being created, or maybe I want to just take the result of it and add my bootloader code to it, like this 4 megs. There are several things that I may want to do, okay, and perhaps I will show where it hooks, but maybe not in this video. Okay, so I define all kind of things, and essentially this is how my directory structure will look like for like the BSP, more or less. And here I have like some notes on the environment. Like if I want to do save env to U-boot, I need to actually add it. So I added it like as a config, and in the U-boot, the config fragment and the config overrides, I implemented it exactly like with the Linux kernel. Okay. All right. So here we have like for building like the bootloaders. Before I add like a source, this loop looks a little bit similar. We go to the common recipes bootloader build blah 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 blah, and if we have a very specific thing under the BSP layer, that we also build the more specific things. So just to look at it, let's see where the layers are under common. Yeah, so for common, like let's have a look. Okay, so we have like the Git repo. I will not go over all of it because it's like the kernel one. Okay, we have a U-boot config that we want to select. We have whether we want to get U-boot from a tarball or from Git. What do we do fragment if we merge them, and so on and so forth. And then there are all kind of like directories, and if it's a tarball, what is the recommended one? And since the version I built it on was 2026.01, if it's a tarball, this is what you're going to use if you have it. And the build script itself is pretty much like the Linux one. We do fetch and unpack. We do config make and make install, where make install itself will only copy like the U-boot binary without all the firmware stuff, like the ATF, what we covered in other videos. So it's going to be, let's start with like with the config. It's exactly like the kernel work, okay? So we have like we copy if it's provided like a default U-boot config, we copy it, and then we do make all def config, and then later for make we just do like the make. It's kconfig, so it looks identical, okay? Even though pay attention that kconfig in U-boot is different than is implemented different. It's not the exact same code than the one in the Linux kernel. And in BusyBox as well, but the U-boot one is much closer to the kernel one than BusyBox to both of them. Just an anecdote. So that's like the common file here. So it's a function that is going to be called from there. Now from the firmware, this is where we actually use my repository here, okay? So we clone it if we need be. I can also have like a fetch here, but it's not supposed to be changed so much or at all. Perhaps I will change it. I just wanted to do the example. Perhaps one of you will change it. So we have like some directories, and not all of them are really necessary, and we use the build fip script as I promised. All right, so we use it, and we use like the copy to media image like in the Flasher script, and this is what I like post and pray. So this is the general one. Now let's look at each one of them. Let's start with the easy one. For the ext Linux config, this is the image that we'll build, device tree, initramfs. Of course, it can be also compressed, and Ubuntu knows to handle to load compress kernel images in ARM. It's not the busy image that x86 always supported. Usually you would have like an ARM uimage or stuff like that in recent kernel, and Ubuntu, that's what you have. You have like image GC by default in recent kernel. It's good. And these are like the kernel command like parameters. So this is like for the eMMC. This is just nice to have like the boot from eMMC and so on. The on-demand frequency CPU governor was in order to, I mentioned in other videos several times that there was like an overclock BL2 and ACS image, like the memory timing. So to overcome that, if I want to early console, I provide it, and this is very important for the RAM disk and hardware BSP. I'll cover it also in this video, I believe. So this is like how it will look for the installed one. And for the removable media one, we have wait for removable media. Okay, and we also have like the installer tactics. Although, so if you already have the system installed, installing for this will override it. Otherwise, we have like this trick that does like AB update. So that's like what I said. No KSLR is absolutely optional. We can use it, we cannot use it. Some security feature the SLR and so on. So that's for the Ubuntu, okay? And for the build configuration of Ubuntu, look what we have. I mentioned it in a previous comment. We store the environment on the eMMC 3 meg mark, okay? And we use the default device tree here. And we add some more compression if we want, for example, to load kernel from other projects that use LZO, okay? And the image type is ubuntu.bin. It's used when we like install. And we can use fragment. The idea with using like fragment in the build strategy, it makes it easier to provide quoted strings, for example, in a file. Okay, so when this is the merge strategy, then the config overrides will find themselves like in intermediate files, and then we don't need like to merge all these kind of things. You can do other things as well. You can use a config, and it's just fine. Okay, so that's for the bootloader, very much like the kernel ones. So we have this is empty because it's under the kernel, and because we didn't provide Ubuntu one, so let's get rid of that. Firmware, we did not use any pre-builds. We built things ourselves, so that's fine. So we covered the bootloaders. Let's go to kernel, something that we already know. Okay, so the build config. List of dev config is irrelevant once we have config src path, and we have this config src path under config. I'm opening it. I will open it here, the one without a fragment. And in addition to it, we also have, there were supposed to be a couple of more, I think. Interesting, maybe it needs to be refreshed. So in this, we have a list of config fragments where I put support for Ethernet, support for Mali DRM render node. Why do we need this? We need this to have like the render 128D node. So if somebody wants to do some GPU calculation and not just use the video processing unit to output stuff, then they can do it. So actually, I'm a little bit puzzled. There were supposed to be more things here, for sure. Like 1000% sure there were supposed to be more things. And let me go ahead and see what happened. Perhaps I rebased and squashed some things. Perhaps I deleted something. And this will not be so good. Okay, that can't be all. Let me pause for a second and see what's going on here. Yeah, so you know what, maybe I'll need some time to merge it and I'll keep explaining regardless, but like the additions that I had here are some initramfs parameters that you can see here. Forget about the BuildOS, it's like for the caches. Let me start again like with a stash list dash p. Okay, so we have the extlinux that we looked at, and there is a configuration for the sound. You heard like this sounds like in the videos. And the misc is empty, it's just a placeholder to add some more things, okay? So the other difference would be adding these fellows here, all right? Like not just the Ethernet and the DRM render node, but also the audio ones, okay? And in the general, I already put like the HDMI and like the display and the graphics and so on. Okay, so if I actually do want it, so let's do, here there is a change. So we need to be careful of it. Let's just add for now. I mean, it's just white space, right? Yeah. So I'll be cautious here. And then I'll of course rebase BSP. Yeah, okay. And let's dash pop. Okay, so that's what we have here. Yeah, so it's exactly like what I intended. So let's go ahead and add all these fellows, and I'll worry about it later. I added some debugging things there. Okay, that's a note for myself, you will not see it later. Alrighty, so it did look weird because it was weird. So we have here like the other configuration. So these are like the kernel configs. There were other videos and tons of like information on doing that. So we already know that. And then there is like there is one missing part. We did not want to provide more DTB, so that's fine. The build Linux kernel has a specific way of looking at the DTB installation. One can decide that they want all the DTBs in the world. Here we just say no, we just want something that is very specific, okay? So that's what we're going to do. And this guy, I think I need to remove it from the code, these two ones. I think no, but I think they're not in use, yeah. So let me get rid of it. And I mean, I could have those, but nobody uses them. I mean, perhaps I clean them on the QEMU BSPs as well, because this was like the intention. Like if you can, and like the kernel versions are compatible, use them. So I'll clean them just for this. Alrighty. So the build Linux kernel just overrides something that the kernel itself would call, and we can see that after we build, we get like the DTB, okay? Like for all the install DTBs that we have. We have similar things like for the modules, so on. By the way, I deliberately did not put modules here just to make the explanation simpler. One of the exercises that you may see like in the courses is to go ahead and make sure that you pack like the right modules in either the initramfs or the rootfs, and not just have like this pre-build. And it also has to do with cleaning up the kernel build so that it will be smaller and that it will be faster to build. And there is a repository for that that is very detailed and very, very, very fine-tuned and crazy fast. I mean, crazy in a good way. Fast, super fast. For some of the QEMU builds. And I deliberately put things that are as close as the default config. They use the default config, then add some things. like for the vertical sound and stuff like that in the QEMU. So I chose a method that is was a little bit similar here. Okay, I could also start like with the vert config for ARM64 with the def config, that has support like for the vert as well, and for tons of things like NVIDIA and all kinds of drivers and Qualcomm and Samsung and you name it, and just add like the fragments for that. So last thing, two things. One, we add, if we have like the XT Linux bootloader, we add to the fat layer under X Linux the file that we already saw. All right. So let's see where this nice fellow is called. So BSP imager. We have like this nice script, the pre and the post. So let's look at them. So when we pack the images, okay, this is like in the common, then we're going to run list of scripts before the main scripts that are the common ones, okay, like for packing, for creating the ext4 file system from the system, and from doing like the recovery tarball and so on and so forth, like the OTA tarball and so on. So these are like the main ones, what I just mentioned. And after that, we're going to use a post common list file, which are these ones, like the post common list config BSP imager post common list of image creation scripts to run. It's very specific, it's for the BSP itself. So if we look at that, let me just get to that. Yeah, so if we look at the post ones, exactly what I promised, like the FIP installed here, and we use copy to media. But this time we don't just use to SD as I mentioned like in the videos where I had like the SD file, but we also say file. Why do we do it? Because then we are going to copy to a file and not complain that, hey, it's not like a block device and what kind of checks that I have. So this is essentially the entire BSP flow. The cleanup here was or is minimal. We can use it to add also other bootloaders, and you can use it to port to other architectures. So I already have, and you might already have, depends who you are and when you see it, like the equivalents for this for the RISC-V BeagleBoard, for the BeagleBone Black, like for both ARM and RISC-V, for a couple of Raspberry Pis, pretty much based on, I uploaded some kernel build scripts that were used only like to build like the Raspberry Pi script, so it's pretty much there. For the Qualcomm Dragon Board 410C, for some Toradec stuff, for some other Qualcomm SOM things, and for a lot of like other boards, but you will not see it, okay? Sometimes you will write it, depends on who you are, if you're like a student of mine, and like what we do together. So, or if you're a customer, but it really depends, okay? Because there's like the public project that has been, released, and it took so much time to release because there's so much private stuff that is either needs a lot of care to port, or I just cannot port it for all kind of legal reasons. So this is the entire chain, and this is how a BSP is made. And as I mentioned before, what we would want to have is this layer is BSP, recipes, blah, 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 blah. So that's how it was created. And that's it basically. So the rest of the build system, I mean, it's generic, you do what you do. And I think it's been comprehensive, and it should teach you how to work with it. And this is like a very, very complete example. Perhaps on the upload it will be a little bit different than what you saw, including what I changed like on the fly. I would want to separate it from the project. The thing is that when it's on the same project, it's easier to go over it. So this covers completely the building itself. I will add perhaps another video that will cover the BSP part inside the initramfs. I wanted to do it in the same video, but it is slightly another topic, so perhaps I'll do it separately.